Okay, this is your Chapter 6 final exam answer video. The first 10 questions we have here, this is question 1, are true and false. So the expectation was you answer true or false, but you support your answer with some work. So the first question says 1.5 times 2/3, and then it has the greater than less than symbol. That actually means it's greater than because it's eating what you just said. So 1.5 times 2/3 is greater than 1. In order to prove whether this is true and false, the first thing you should do is multiply them together. Now, what we talked about is when you have a mixed fraction, you should always change it to improper. So we're going to change 1.5 to 3/2, multiplied by 2/3. Now, some very smart people realize pretty quickly that 3/2 and 2/3 are the reciprocal of each other. And they learned early on that if you multiply a fraction by its reciprocal, you always get the answer 1. But we're just going to work it out anyway. 6/6 is the answer, which of course is equal to 1. And since 1 is not greater than 1, we say false. They are not indeed, they are actually 1 is equal to 1, not greater than 1. So the answer is false because 1 is actually equal to 1, not greater than. In our second question, we get another question just like it. It's 1 2/5 multiplied by 3. So again, we're going to treat 1 2/5 as an improper fraction. And we're going to treat the whole number 3. We can either treat it as 3 and say, well, 7/5 tripled is going to be how many fifths? And the answer is 21/5. Or if you want, you can treat the whole number as over 1. Either way, when you multiply the numerators and denominators, you get 21/5. So really, this is the exact same question. Is 21/5 greater than 5? In order to figure that out, we got to change this back to a mixed fraction. That's going to be 4 and 1/5. And since 4 and 1/5 is not greater than 5, our answer for number 1 is false. It's actually less. Question 3, we have the sum of 1/4 plus 1/5 being greater than the product of 3/4 times 3/5. In order to work it out, we're going to actually measure your ability to add two fractions together. We've got 5/20 plus 4/20. So the sum of those two fractions is actually 9/20. And the product, if I multiply my numerators and multiply my denominators, is also 9/20. So is 9/20 greater than 9/20? No, so our answer is false. They are indeed equal. So the correct answer is they are equal, not greater than. Our next true and false is 1/2 combined with another half is 1. So 1/2 combined with, remember, combining is not multiplication, it's addition. So 1/2 combined with another half is 1. The answer is true because 1/2 plus 1/2 is indeed 1. Next question for true and false is the reciprocal of 2 3/5 is 5/3. Remember what we said before, that in order to find the reciprocal, or the flip, where the numerator and denominator are flipped, if it's a mixed fraction, the first thing you need to do is change that mixed fraction to improper, and its reciprocal would then be the flip of the numerator and denominator there. So the answer for is the reciprocal of 2 3/5 5/3? Yes, it is. So your answer is true. Our next question says a good estimation for 2/5 divided by 3/10 is a little more than 1. Back to what we talked about for money. We said if you think about 2/5 of a dollar, that would be 40 cents, right? 2/5 of a dollar. Divided into piles of 3/10 of a dollar would be 30 cents. So this is how much money you have divided into this size of pile. You have 40 cents divided into piles of 30 cents. You can make one pile and have just a little bit left over. So if we estimate it, your estimation would be 1 and a bit. So therefore, your answer for this is indeed true. The next question says 5 3/4 is greater than 27/4. This is actually a grade 6 question when we learned about mixed fractions and improper. So if we change this, it's going to be 23/4. Is 23/4 greater than 27/4? No, it's not. So your answer is false. You have less if you have 23/4 than you do if you had 27/4. Another way you could have done that is change this to 6 3/4. And we can see very quickly that 6 3/4 is greater than 5 3/4. 15 halves is equal to 7 1/2. Well, if I change them both to mixed, then yes, they are. And if I change them both to improper, 7 halves is going to be 15 halves. Either way you have it, the answer is true. They are indeed the same thing. The next question says a quarter of a fifth is represented numerically as 1/4 divided by 1/5. I guess this is really a test question is, do you remember what we wanted the word of to mean? So a quarter is of course a quarter, and a fifth is of course this. But the word of is actually a multiplication. So the correct answer is false. They're not the same thing. It should be a quarter times 1/5, not a quarter divided by 1/5. And finally, the last question, multiplying a number by its reciprocal will result in 0. The answer for that is false. If I take a fraction and multiply it by its reciprocal, I don't get 0. I actually get 1. So anytime you multiply a fraction or any number by its reciprocal, you will always get 1, not 0. Okay, now we're on to our numeric responses. So we just have to solve it using an algorithm. 5/6 multiplied by 3. If you said you have 5/6 and you triple it, obviously you could draw it, which is very rudimentary. Oh, that's terrible. Let's try that again. Oops, not that far back. Went too far. Went too far. So 5/6, so cut it in half in 2 parts and 2 parts. If we were drawing it, 5/6, and we wanted to triple it, we would simply draw that 3 times. That would be tripling it. And we would say, how many fifths do we have in total? We have 15/6. Of course, we got past the modeling stage and said, if you treat the whole number over 1, because that's really still 3, multiply 5 times 3, you get 15. 6 times 1, you get 6. That would be equal to 2 and 3/6, which is equal to 2 and 1/2. Your next question says, question 12 says 1 3/4 times 4. So we're going to change our improper fraction to 4/3 and multiply that by 4. Or, of course, the easier way to do it is think of 4 as being 4/1. Multiply your numerators, you get 16. Denominators to get 3. That is 5 and 1/3 as a mixed fraction in lowest terms. Question number 13 says 3/8 divided by 4, or 3/8 divided by 4 represented this way is probably the best way to think of it, because our easiest way to solve a division is to keep your first fraction, change the multiplication, and the reciprocal of 4 is actually a quarter. And now that you have it written that way, multiply your numerators to get 3, multiply your denominators to get 32, and you have a final answer of 3/32, or 3/32. Question 14 says 1 1/4 divided by 2. The easiest way to do it is change your 1 1/4 to improper. And when you divide by 2, we're going to keep the first fraction, change the multiplication, and the reciprocal of 2 is actually a half, because we have to think of 2 as actually being 2/1 in order to flip the numerator and denominator to get its reciprocal, right? Once we have that, we're multiplying our numerators to get 5, multiplying our denominators to get 8. Our final answer is 5/8 for question number 14. Question 15 says 2 1/6 times 1 5/12. When using improper fractions, the easiest thing to do is just change them both to improper. That's 13/6 multiplied by 17/12. Once you get this, you're like, hold on, can I cross reduce there somewhere? Hopefully to God I can, and I can't. So we're going to multiply our numerators. 13 times 17, I don't know off the top of my head. 13 times 17 is 182. Over 6 times 12 is 60 is 72. Something's weird about that. How come? Oh, that's not supposed to. Sorry, 13 times 17 is not. I made a mistake there. 13 times 17. 13 times 17. Must hit the wrong button there. 221. 221. It's 221. And now that we have that, we don't. It's not the lowest terms, but I can't seem to divide it by anything because 221 is not divisible by 3 or 2 or 5 or 10 or anything. So how many 72s in 221? Well, 72 times 3 is 216. So there's 3 of them. And that means I have 5 left over. So 5/72 is your remainder. Question number 16 says 4/5. No, I must have copied that down wrong. Hold on, did I skip one? Oh, I did skip one. Hang on one second. Let me just enter it here. So our next question, number 16, is 4/5 divided by 4/15. The easiest way to do this, keep your first fraction, change the multiplication by the reciprocal. Now, if you are wise and sagely, you cross-reduce this. 4/4 becomes 1/1. Now, some people made a huge mistake here. If you think of 15 being over 5, it will reduce to 3 over 1 because both are divisible by 5, correct? So you put a 3 here and a 1 there, and when you multiply your numerators, you get 3, multiply your denominators, you get 1. Your final answer, regardless if you cross-reduced or reduced in the end, will be 3. Now on to the next question. 5 divided by 1/8. Remember, when you have a whole number, think of it as being 5 over 1. Keep your first fraction, change to multiplication by the reciprocal. 5 over 1 times the reciprocal of 1/8 is 8 over 1. Will give you 40 over 1, which is simply the whole number, 40. Now, the questions 18 and 19 are your bed mass. So remember, you have two operations here. You have addition and you have multiplication. When you have more than one operation, you need to follow bed mass. So here we're going to do our multiplication first. So I'm going to ignore the 1/2 plus. And I'm going to multiply 2/5 times 5/6, which is 10/30ths. Now, a smart person right now would probably put it the lowest terms, which would be 1/3. And if you cross-reduced here, you would have got 1/3 as well. But we're not. We're just going to treat it like this. We're going to put 30 as our common denominator. It's fine if you did. If you had lowest terms, 1/3, it's fine. You're going to have 15/30ths, which is going to keep your denominator and add your numerators. That's how you add, which is different than multiplication. 25/30ths, which in lowest terms, because both are divisible by 5, is 5/6. And your last in your numeric response side says 2 1/4 take away 1/5 divided by 3/8. Two operations, do your division first. So it's going to be 1/5 multiplied by the reciprocal, which would be 3/5. That's going to be 8/15ths. So 2 1/4 take away 8/15ths. Now that we have subtraction, the easiest way is to simply treat your mixed fraction as improper. Common denominator will be 60. That's going to be 90 plus 45 is 135. 8 times 4 is 32. That's going to get you 167 over 60, which is 2 and 47/60ths. Oopsie daisy, I made a big mistake. My bad, I added them together instead of subtracting. It should be 103 over 60, which is equal to 1 and 43/60ths. Ignore everything I just said there before. I made a mistake. I forgot it was subtraction, not addition. Okay, which takes us now to finally our story problem side. The first story problem says, at a baseball game, 240 people were in attendance. 3/8 are men, 1/5 are women, and the rest are children. What fraction were children? So I'm going to draw the entire group of 240 people as a rectangle. Now 3/8 are men, which is just a little bit less than half. We'll put men in here. We'll put 3/8. And then 1/5, which we'll pretend that's 1/5. That's women. And the rest are children. So the first thing you probably want to do is figure out what fraction of all the people are men and women. So in order to do that, we're going to add those two together. Common denominator is 40. 15/40ths and 8/40ths. So 23/40ths, if I was to erase everything in here, and even erase the line, right, and say men and women, 23/40ths are men and women. And since the rest are children, and 40/40ths is all of them, that means that our answer for that one has to be 17/40ths are the fraction of people in attendance that are children. That's our answer for A. Okay? And for B, 17/40ths of 240 people are children. So therefore, if I change my of to multiplication, the operation I can do, that's a 0, is actually this. How many 40s are in 240? There are 6 of them. 6 over 1, which means 17 times 6 over 1 times 1, which would be 102 people are children at the game. Our next question says Alan makes $18 an hour. Bob makes 1 3/4 times as much as Alan. And Cecil makes 9/10 or 90% as much as Bob. How much do Bob and Cecil make an hour? So I'm going to start with a big B here. And since Bob makes 1 3/4 times as much as Alan, since Alan makes $18, Bob is going to make 1 3/4 times that. So as an expression, that's what we're going to use. $18 is a fraction, is 18 over 1, multiplied by 7 over 4. Probably would be helpful if I cross-reduce this to 9 over 2. Don't have to, but it'd be easier. That's 63 over 2, which means that's 31.5, or $31.50. $63 divided by 2 is $31.50. And Cecil makes 9/10 as much as Bob. Now, as a dollar amount, that's what Bob makes. As a fraction amount, 63 halves of a is what he makes as a fraction. So 9/10 of Bob's amount. This expression represents Cecil's money, which is 540 and 27, 567 over 20. If I take my calculator, say what is 567 divided by 20? It is 28.35. So Cecil, makes 28.35 an hour, or 28. How much is 28/20ths? 28/20ths. 28/20ths is 560, which means it's 567 and 7/20ths as a mixed fraction, or 28.35. Now the next part was pretty tricky. It was a bonus question, so you didn't have to do it. It says if all three work a 5-hour and 45-minute shift, how much will they make combined? So let's just take all three of them as being, so Alan plus Bob plus Cecil, or $18 for 1 hour plus $31.50 plus 28.35. Okay. So let's just use this in terms of decimals, not fractions. If you think about how much they make per hour, take my calculator out. $18 plus how much was the other one? 31.50 plus 28.35. The answer is 77.85 an hour. Right? This is much easier to do with decimals instead of fractions. And if you think about 1 hour or 5 hours and 45 minutes, that's how much you make for 1 hour. If you multiply that by 5 3/4, because 45 minutes is 3/4 an hour, or as a decimal, 45 minutes is decimal 75 hours, then when you take $77.85 and multiply it by 5 hours and 45 minutes, 3/4 of an hour, the final answer would be they would make 447 and roughly approximately 64 cents for that shift. If you did it as fractions, it would be 18 plus 31.5 plus 28 and 7/20ths. That's how much they make for 1 hour. And you would take that and multiply it by 5 hours and 45 minutes, or 5 3/4. So obviously, if you did this as a fraction, this was a lot harder to do than this was, but the same thing is true. We added all three of ours first, which is what we're doing here, and then we multiplied it by 5 3/4, which is what we're doing here. But either way, you got $447.64. Students in Mr. McDonald's math class daydream for 7/8 of the class. That seems about right. Of this time, the 7/8 of the time, 1/4 is spent thinking of ways to earn more Jelly Bellies. What fraction of a math class is spent daydreaming of just Jelly Bellies? So half of the 7/8 they daydream is what the word form would be as an expression. It'd be 1/2 times 7/8. Therefore, the answer is 7/16 of a day of a class is Jelly Belly dreaming. Right? That would be the answer for that. And then it says if a math class is 48 minutes long, so then 7/16 of the class, or of the 48 minutes, is the expression when I treat the whole number over 1. Cross reduction works so well here if you did 48, because you know there's 3/16 and 48. But if you didn't cross reduce, whatever. It makes it so much better if you did, because that's 21 over 1, which is 21 minutes. So therefore, they're spent daydreaming for about 41 or 21 minutes of the 48-minute class. And finally, your last question says, Adam cut 3/4 of a lawn, his brother Brian cut 1/3 of the remaining lawn, and his sister Candace cut the rest. First thing I'm going to do is draw it. It always helps me think about it. So Adam cut 3/4. So I'm going to divide it into quarters, and I'm going to put Adam, Adam, and Adam. So this part of the lawn that's now shaded in yellow is already cut. Okay, Adam did all of this work. And Brian cut 1/3 of the remaining lawn, not all of the lawn, but the remaining lawn. So if I cut this into thirds, Brian cut this, and Candace cut the rest. So as a straight up picture, that's what that looks like. If I think about it, Brian cut 1/3 of the remaining lawn, that white part, which was 1/4 of the entire lawn. So Brian cut 1/3 of 1/4, which is 1/12 of the lawn. And that makes sense because this is actually 1/12. If I put parts here, there are 12 equal parts. Brian cut one of them. What fraction did Candace cut? Candace cut 2/3 of the 1/4, or 2/12, or in lowest terms, 1/6. And finally, if it takes 15 minutes to cut 1/12 of a lawn, how long did it take Candace? Well, since Candace did 2/12, she did 2 15-minute intervals, so therefore, Candace took 30 minutes to cut her part of the lawn.